So, in a world where data plays a central role, businesses aim to anticipate and prevent challenges such as churn, which refers to the loss of customers over time. To address this, they rely on machine learning tools like supervised learning, a technique that predicts future behavior using historical labeled data. Classification is a key method within supervised learning, involves categorizing data points into predefined groups. For change prediction, this typically takes the form of binary classification. For example, will a customer leave or stay? One of the most effective algorithms for this task is logistic regression, which predicts the probability of an event, such as churn, occurring by transforming data into probabilities between 0 and 1. It enables businesses to identify at-risk customers and take targeted actions to retain them. This presentation will explore these key concepts, showing how supervised learning, classification, and logistic regression can empower businesses to effectively predict and address customer churn. So first, we're going to see the supervised learning, predicting customer churn. Supervised learning is a fundamental machine learning technique where a model is trained on labeled data that is, example, with known outcomes. For instance, a company may already know which customers have canceled their subscription, labeled as 1, and which have stayed, labeled as 0. Using this historical data, the model learns patterns that help predict future behavior. The process begins with labeled data. This could include features like customers' age, frequency of purchase, or the duration of their subscription. The model analyzes these features to identify relationships, such as how low app usage might indicate a high likelihood of churn. Once trained, the model can evaluate new customers and predict their likelihood of leaving the service. For example, if a customer shows declining activity over time, the model might assign a high probability of churn, signaling the company to take preventive action like offering incentive or personalized promotion. Supervised learning is particularly effective in this context because businesses already have a clear history of customer behavior to build upon. So next, we're going to see the classification. This is how you're going to organize the data for decision making. The classification is a type of supervised learning, assigning categories to data points. In customer churn analysis, the goal is to classify customers into two categories. We have first those who will stay, the class 0, and those who will leave, the class 1. This is known as binary classification, as there are only two possibilities of outcomes. However, classification can also involve multiple categories, like grouping customers into loyalty tiers, for example, gold, silver, or bronze, which is called multi-class classification. For churn prediction, binary classification is particularly useful. Imagine a company like Spotify wanting to predict if a premium user will cancel their subscription. The model could analyze features such as the number of playlists created, frequency of listening, or time spent on the platform. Based on these inputs, the model identifies at-risk customers and enables the company to act, for example, sending promotional offers or curated playlists to retain users. This targeted approach not only improves customer retention, but also ensures efficient allocation of resources as the company focuses on users most likely to churn. Then you're going to see the logistic regression. This is a practical tool for binary classification. While classification can be performed using various techniques, logistic regression is a popular choice for binary problems like churn prediction. Unlike linear regression, which predicts continuous values like the price of a product, logistic regression is designed to predict probabilities between 0 and 1, making it ideal for yes or no scenarios. Logistic regression works by applying a mathematical function called the sigmoid function. This function transforms raw data into probabilities. For instance, the model might calculate that a Netflix customer has 35% chance of canceling their subscription Based on this probability, the company classifies the customers as likely to churn if the probability is greater than 0.5 or likely to stay if it's less than 0.5. So we have some formulas you can see there. So we have a concrete example of Netflix, who might analyze variable like the number of movies watched, subscription duration, or frequency of use. If the model predicts a high likelihood of churn for a specific customer, Netflix could take proactive steps, such as offering a 3 months of service or a discount to encourage the customer to remain subscribed. Logistic regression has several advantages. First, it provides easily to interpret results. For example, the model might show that low usage frequency increase the likelihood of churn by 20%, allowing the company to focus on engagement strategies. Second, it delivers clear probabilities, enabling business to prioritize high-risk customers. And lastly, despite its simplicity, logistic regression is highly effective for programs like churn prediction, offering accurate and actionable insights.
So now we are going to see the awesome pipeline. So a pipeline is a list of the steps involved in aggregating, organizing, and moving data. Modern data pipelines automate many of the manual steps involved in transforming and optimizing continuous data loads. Awesome is a widely known framework in data science that outlines the essential steps for handling data from acquisition to drawing actionable insights. It is an acronym for obtain, scrub, explore, model, and interpret. So awesome is a framework that outlines, O is for obtain, so it consists of collecting data from various sources. This could be through databases, files, or from the web. S is for scrub. It's about cleaning and preparing the data. It involves removing errors, filling missing values, and transforming data into a usable format. E is for explore. It's about analyzing and visualizing the data to understand its structure and patterns. So it often involves creating charts and summaries. M is for model. So it's about building predictive models using techniques like regression or classification. So machine learning and statistical models are applied. And finally, N is for interpret. So it's about evaluating the results and drawing conclusions. So awesome helps guiding data scientists through a structured process, ensuring that all critical aspects of a project are covered from data collection to result interpretation. So in this case study, we wanted to find out the reasons behind customer churn and predicting future customer churn of a bank that wants to increase its market share in Europe. So this will help the marketing team. So for the first step, obtaining the data, we imported the banking data provided by the bank and made some initial checks, such as seeing how many rows and columns are present. After generating the 5 rows, we could see the following. So it's a table that shows information about the different customers. It also gives information about the location, gender, and their balance. So this is the starting point to analyze their behavior. Also for the scrubbing part, it involves data type conversion, renaming columns, or missing value imputation, because sometimes the data is not collected or recorded. First, we checked for missing values with a code which gave an output of true in the columns with missing values. We were able to see the missing values in gender, age, and estimated salary. We have also tried to see who has a credit card and who hasn't. So with the has credit card column, we could see that it has a minimum value of 0 and a maximum of 1. So that means that this variable is categorical. So 0 means that the client has a credit card, and 1 means that they don't. So after generating the results, we showed that approximately 70% of customers had a credit card and 29 don't. So by exploring the categorical variables, we can find out which values can be used to replace missing values for the categorical variables. This ensures that all the missing value treatment can be done at the same time. So to fill the missing values, we used test statistics such as mean, mode, or median, and predicted the missing values using a machine learning algorithm. So very quickly, we used the describe function to find out the descriptive stats of the data. So because of this, we could find the missing values and perform missing value imputation for the estimated salary, gender, and age columns. Then we renamed them because it's also an important step that the columns have the right names so that it's easy to understand. So this involves renaming them to clearer terms. Like for example, we renamed credit rate to credit score so that it's clearer. And also we also need to check that the columns have the correct data types and that the target variable, in our case, it's churn, is placed where it's easy to spot. So typically at the end of the data set. And so far we have loaded, cleaned the data, and now we have to explore the relationship between the columns themselves and with the target column.
Now we will see the exploring the data. Exploring the data is an essential step before creating a machine learning model. It allows us to understand the data set and answers we apply appropriate algorithm later. This step generally involves with statistical overview, correlation analysis, and the visualization. So first, the statistical overview. This step involves summarizing the dataset using descriptive statistics such as central tendency with mean, median, the distribution with minimum, maximum, and the target variable inspection. The purpose is to get an overview of the data structure and understand trends. So in the case study, first we inspect the target variable to see how many of the customers have churned. And here, the following output tells us that 7,963 customers didn't churn, whereas 2,037 customers churned. After, we can inspect the percentage of customers who left the bank. And after that, we can get a statistical overview of the data with the code data described. Now we can inspect some of the statistics such as mean and max. These statistics should also help the marketing team and senior management to understand whether a feature is important for model training and what kind of data they are dealing with. So we inspect the mean attributes of customers who churn and also find the median attributes of the customers. And here the average credit score of customers that churn is about 635.35, and the average age of the customers that churn is 44 years. We also find note that the median number of products bought by customers that churn is 1. After this, we can do the correlation analysis. The correlation measures the relationship between two variables, and the correlation coefficient ranges between 1. This is indicate a strong positive relationship, and -1, which indicate strong negative relationship. So why analyze correlation? It's to identify relationship between features and to determine which features might impact the target variable. And how to analyze correlation. There are two simple steps by calculating the correlation matrix and then visualize it with a heat map. So I put the code here. And in the case study, we can see the number of projects and balance have a negative correlation. And there is also a positive correlation between the balance and the age. So in this correlation plot, it appears that there is a negative minus 0.3% relationship between the number of products purchased and the balance. And finally, to exploring the data, there is the visualization with the exploratory data analysis. So this is a statistical approach that uses visualization to understand data distribution and relationships between variables. By visualizing data, we can identify patterns, trends, and anomalies, making it easier to create more accurate predictive models. There is different types of analysis. First, there is univariate analysis, helps us understand the distribution of a single variable. For example, to analyze employee salaries, we can use a histogram or a bar chart. There is bivariate analysis, explores relationships between two variables. For instance, we can examine the impact of age on salary using a scatter plot. And there is also a multivariate analysis that compares more than two variables to explore complex interactions. So we can see key Python libraries and common Python commands to create this visualization. And with this example, first there is an univariate analysis with the age. Imagine we want to analyze customer churn in a bank. We have data set containing variables like age, balance, country, and churn status. And by analyzing customers' age, we observe that most are between 30 and 45, making this age group the largest in our data set. Here there is an example of bivariate analysis. And by examining the relationship between gender and churn, we notice that women are more likely to leave the bank than men. And the third example is a multivariate analysis. And when we're comparing the number of products with bank balance, we find that customers with multiple products generally have higher balances. However, some of these customers still churn, which suggests other factors are at play.
Data modeling involves developing a model that defines the structure of data, and it's used to make prediction or draw conclusion about new data points. This process encompasses both building the machine learning model and identifying the important features or columns to include in the model. This section will be divided into two key parts: feature selection and model building. Before building a machine learning model, it is essential to perform feature selection in scenarios like customer churn prediction, where data sets may contain many columns. Not all features will significantly impact the model's performance. Including irrelevant feature can reduce the model's accuracy, especially when using algorithms like linear or logistic regression. Feature selection addresses this by identifying and retaining only the most relevant feature. For example, if you're predicting customer churn, knowing a customer age might be relevant, but their favorite color is probably not. The benefits include reducing training time, reduce overfitting, and improve model accuracy. There are several methods for feature selection. like invariant feature selection, recursive feature selection, principal component analysis, and tree-based feature selection. For this exercise, it demonstrates the process of feature selection using a random forest qualifier to predict customer churn. The data set includes both numerical features and categorical features. Categorical data is encoded into numeric value to make it sustainable for machine learning. The data is then split into training and testing set, ensuring the class distribution is preserved. A random forest is trained on the data, which not only predict churn, but also rank features importance. Key insight from this analysis show that the strongest predictor of churn is age, estimated salary, credit score, balance, number of products, while other like gender and geography have minimal impact. So for the recommendation, we can focus on the top features, age, estimated salary, credit score, and balance, and the number of products. We can develop a customized offer for specific age group customer, provide financial guidance to customer with low credit score, engage customer with extremely low or high balance through special programs. We can also simplify the model. The feature that contributes less to the prediction could be excluded from the model without significantly affecting accuracy. It makes the model simpler and faster. And then we can segment the customer. Age and salary are highly predictive, so you could create customer segment based on this attribute and design a specific retention strategy for each group. For modeling building, it's the process of creating and training a machine learning model to learn patterns in data and make prediction or new unseen data. It involves selecting an appropriate algorithm such as random forest and feeding it training data to establish a relationship between input features and the target variable. During this process, the model learns to recognize trend and correlation that can be applied to solve the problem at hand, such as predicting customer churn. The goal is to create a model that is accurate, efficient, and generalize well to real-world data while avoiding overfitting or underfitting. This exercise demonstrates the use of logistic regression to predict customer churn by identifying key features that influence a customer likelihood to leave using the most relevant features. The model was trained to assess the impact of each variable. For instance, age was positively correlated with churn, meaning older customers are more likely to leave, while number of products had a negative correlation, indicated that customers with more products are less likely to churn. For a customer with attribute like age 50, balance 1,100, and number of product 2, the model predicts 38% chance of churn, and empathizing the model's ability to calculate individual risk probabilities. The overall model achieved 79% accuracy, reflecting reasonable performance in correcting identifying churners and non-churners. For the recommendation, we could leverage these insights to develop target retention strategies and optimize resource allocation. For example, customers with higher churn probabilities, such as those aged 35, 45, or with balance between 75,000 and 150,000, could be prioritized for retention efforts like personalized discount or loyalty programs. Insight into feature importance allow businesses to take action, such as promoting cross-selling opportunities to customers with fewer products, or addressing concern for female customers who exhibit higher churn rates. Additionally, the geographic difference in churn, like between Germany and France, could inform region-specific marketing campaign by continuously monitoring and refining the model. Analysts ensure that the business stay proactive in minimizing churn and maximizing customer satisfaction. The analysis of this activity focus on understanding and predicting customer churn in order to help the marketing team develop targeted retention strategies. Through the use of the random forest classifier, we identify key drivers of churn, including features such as average day delinquent, month-over-month increase in usage, and average call on weekday. The most important feature in churn was average day delinquent, followed by percent increase month, and average call weekday. Using this insight, we built a logistic regression model that enabled us to predict churn with high accuracy. For example, we found that a customer with high delinquency and usage increase has an 81.9% chance of churning. By leveraging this model, the company can proactively target high-risk customer with retention efforts, such as offering discount or improving customer services, which can ultimately enhance customer retention and reduce churn rates.
So in conclusion, predicting customer churn is a crucial aspect of marketing and analytics because it helps companies improve their strategies and use resources more efficiently also. In this presentation, we looked at how to apply a data science pipeline to solve machine learning problems. We also focused on logistic regression and understanding its principles and comparing it to linear regression. Supervised learning is a powerful tool, but its success depends on rigorous data handling, thoughtful feature selection, and continuous evaluation. As we advance, applying these concepts with precision will be key to unlocking value in various industries, from finance to healthcare.